We'll start with context-free language. So the hierarchy, if you remember, a grammar generates a language, and the language is accepted by an automaton or by any machine, finite automaton, Turing machine, or a push-down automaton, or a linear bound automaton. So any machine, so language will be accepted by a machine. So grammar will generate a language. Okay. So we'll see the formal definition for, so type 2 grammar, that is context-free grammar, generates a context-free language. So how do I formally define a context-free language? So if this is our grammar's formal definition, this is the formal definition of the grammar, V or N, non-terminals, terminals, production rules, and starting symbol is a context-free grammar. The language of G, L is a language generated by G. So G generates this language. So the language generated by G is a set of terminal strings. As we know, the strings generated cannot have any non-terminals. Non-terminals have to be replaced with terminal symbols. Okay, so it's a set of strings with terminals that have derivations from the start symbol. So you should be able to derive that string from the start symbol. So this, the language of all such possible strings that can be, language is a set of all possible strings that could be generated by the production rules in the grammar, starting from the starting symbol S. So that this is how we formally define it. So W is a string or a word. Okay, the W should be represented by non-terminals. It cannot be represented by non-terminals. It has to be represented by terminals. Okay, so W is a string or a word. So it has to be represented by terminals. You should not have any non-terminals in it. And how am I generating W? So W is generated such that I start from the start symbol S, apply 0 or more production rules, apply the grammar, and generate W. Okay, so this is how we formally write a language generated by a grammar. So context-free language generated by context-free grammar is represented like this. So it is a list. Language is a set of all possible strings. Okay, W is all possible. It's one of the string. Okay, so all possible, set of all possible strings. Okay, and the string should be with respect, our string should be represented in terms of terminals. No non-terminals allowed. And how should they be generated? So from the starting symbol, so applying the grammar, we should generate the word. This is a formal definition for a language, context-free language. Okay. Now we've already seen derivation and how to see parse tree. We'll see it once more and we'll move to ambiguity. Okay. So derivation is a process of, this is called derivation. This process is called derivation. Okay. So generating strings, valid strings from the grammar using production rules in the grammar. This process is called derivation. And we saw you can do derivation in two ways, either keep substituting production rules or keep rewriting non-terminals in place, or you can use a derivation tree, or it's also called as parse tree. Okay, so these are the two ways in which you can do derivations. So this is the explanation for derivation. So we'll start with a start symbol. Then non-terminals are rewritten using productions. Okay, and until only terminals remain at your leaf nodes. So if it's a parse tree, all your leaf nodes should have only terminals. Okay, so start with the starting symbol, keep replacing non-terminals, and till you reach only the string or leaf nodes of the tree having only terminals, then at that position you can stop. Any terminal sequence that can be generated in this manner is a valid string that belongs to the grammar. Okay, if a terminal sequence can't be generated at all using your production rule, then your grammar is invalid. Okay, if you can't generate a terminal sequence, that means your grammar has syntax error, your grammar is invalid. Okay, so the set of strings, all possible strings that could be derived from the start symbol is called as the language of the grammar. Okay, it's denoted by L of G. So derivation is a sequence, applying a sequence of production rule. Remember, it's not mandatory. You have to apply all production rules, not mandatory. Okay, you can apply a set of production rules in order. So in some order, when you apply a production rule, the process is called as derivation. So it's used to get the input string to these production rules. So you can get the strings to you via the production rules. So this is the process of derivation. Okay. So during parsing or during this derivation process, we have to make two decisions basically. So these are the two decisions we'll be making: which non-terminal to replace and which production rule to use for this replacement. Okay, so at every step you will have multiple non-terminals. So you have to make two decisions. First decision, which symbol to replace, which non-terminal symbol to replace, and which production rule should I use to replace that non-terminal. So we need these two decisions at every step. So based on this two derivation, we have two options to derive which non-terminal to replace. So for the first decision, which non-terminal symbol to replace, we have two options. You go for leftmost derivation, keep expanding the left side of the tree, or keep substituting in place from left to right. This is called leftmost derivation. So when I do it the other way, I keep expanding the right portion of the tree, or I keep replacing or rewriting the non-terminals from right to left. That is called as rightmost derivation. Okay, so we can do it in place or using a tree. Okay, so both of these processes are allowed. So there are two types of derivation. So this is based on which non-terminal has to be replaced. If it is left to right or left side expansion, it's called leftmost derivation. If it's right to left or rightmost replacement of non-terminal, it's called rightmost derivation. We'll see it with examples. Okay, so input is scanned and replaced. So first as I told, input is scanned and replaced. So replaced with production rule from left to right. Replaced with production rule from left to right. Okay, so we read from left to right. Leftmost non-terminal is always expanded. Leftmost non-terminal is always expanded. Okay, so let us consider a grammar. So see this grammar. So this is a grammar. Okay, so this is the production rules of the grammar. Okay, production rules of a grammar, set of production rules. So E can be replaced by E plus E. E can also be replaced by E minus B. E can be replaced by A and B. A and B are non-terminals. Plus and minus are also, A and B are terminals. Plus and minus are also terminals. Capital E is a non-terminal. Okay. Now, what do we do? Start seeing from this derivation alone. So this is in place derivation. Okay. So in place, I'm going to replace. So this is leftmost derivation. So I'll start from the leftmost symbol. So let me write it as E plus E. Okay, I'll choose this symbol. So leftmost symbol I'll be replacing. What other production rule I have, I'll try to replace it with minus E. Because, see, why do I choose this rule? I can directly substitute A or B and go, this is the string that is expected. Okay, you are expected to derive a parse tree to generate this string. So I should have a minus. So I should use the production rule that has a minus. So what do? I replace this E with the second production rule. Okay, so I use rule 2. So rule 2 I use and I replace the leftmost non-terminal. Okay, and then I write this E as such. Okay, now I'll use rule 3. Okay, so I've got both the symbols that are required in the string. I can just keep replacing. So I'll replace this one by one, leftmost derivation. Just replace, again, sorry, this is E. So I've replaced the leftmost E. Okay, now the leftmost non-terminal is this. So what is the string expected? A minus B. So I'll replace. So this is rule 3 is used. Here also rule 3 is used. I'm replacing B. Write this E as such. Now the leftmost non-terminal is this E. So what is expected? A is expected. So replace it with A. So this is called as leftmost derivation. So I start from left, keep replacing the leftmost non-terminal with the use of a production rule. I'm replacing it in accordance with a string that is expected. I'm expected to generate this string. So I'm choosing E minus E in this step. Okay. So this is leftmost derivation. Scanning is from left to right. The same thing when you do from right to left. It's called rightmost derivation. So the same string is expected, but we are asked to use rightmost derivation. Okay. So again, E tends to E minus E. I will start with minus. Why should I start with minus? Because I'm going to expand right. Okay. So this also is important. So we should know where we should start with. So there are so many options in our case. So E is a starting symbol, fine. I have 3 different options. In fact, 4 different options, 4 different substitutions are possible. So I see the string, pattern of the string that has to be expanded. So I just I start with this rule. Rule 2 I start. Okay. I start with rule 2. So this is rightmost. So I should expand this. So I cannot again choose E minus E because the plus is expected. So what do I choose to expand this is E plus E. I'm using rule 1. Now I have all the symbols in place. I just have to replace it with terminals. Okay, I'll replace this. So I choose B. I'm sorry, I choose A because my string ends with A. Okay, so I choose A. Done. So this is rule 3. Then A is done. This is the rightmost non-terminal. I go back to the string. So I should be replacing it with B. Again, rule 3. And then this is the rightmost non-terminal. So I'll replace it with A. So I'm getting the string. So this is rightmost derivation. So the second way of doing this derivation is via a parse tree. This is a graphical representation. Okay, in parsing, string is derived using the start symbol. The root of the parse tree is the start symbol. Okay, so root is a start symbol. So that we should remember. Root is a start symbol. All leaf nodes have to be terminals. Okay, all interior nodes that are further expanded, they'll be non-terminals. In-order traversal gives the original input string. I think you know what is in-order traversal. Yes. So when you have a left, when you have a root, and when you have a right, different subtrees you have. In order is like left, root, and right. So pre-order root comes first, then left and right. Post order, yeah, left, right, and then you traverse the root. Okay, so this is in order traversal gives the original input string. Okay, fine. Now we'll see an example for parse tree. For leftmost derivation, we'll see. Now this is my starting symbol. S is my starting symbol. A, B, and C are my terminals. Okay, so I'll start with S and I choose this production rule. So what is the input string? This is the input string that is expected. Okay. So I get a S plus S, I choose that. So plus has to come at the right of my, plus has to come to the right of my string. So I will choose to expand this next, this S next. So I want an asterisk. So I choose the second production rule, S asterisk S. So this S will be replaced by S asterisk S. Okay. So remember, for every symbol, terminal or non-terminal, have a branch of the tree. Okay. So this is S asterisk S. Okay. Now I've got the two symbols. I just have to replace it. Okay. So replace this with A. Okay. Then this with what? B. This should be B. Step by step, I'm doing it. So leftmost. So replace the leftmost terminal. So A is done. Then the second leftmost. So this is replaced, terminal is reached. So now this will be replaced. And the next step, left to right, this will be replaced. So you have to read from bottom to top. Okay. How do I read bottom to top? So the bottommost operator is this. So they'll read it like this: A asterisk B plus a C. So this is how we'll read A asterisk B. Ensure all the leaf nodes should be terminals. Okay, so A asterisk B in order traversal, then a plus and then a C. So this is leftmost derivation. So since this is leftmost derivation, what did I do? I have to retain. So you might have seen using stacks for expression evaluation. Am I right? So why do I use stack? Last in, first out. Okay, so plus has to be my last operator. So I put it first into the stack. Okay, so that's how you do expression evaluation. You might have done that. So that's why I use this expression, this production rule first, and then I go for the asterisk production rule. That depends upon the input string. Okay, input expression actually to be evaluated. Okay, so this is leftmost derivation. Let us do the same with the rightmost derivation. See, as we did with in place, my choice varies. Okay, my choice varies. So it is asterisk. First, I choose S asterisk S. Okay, so I expand from the right. So that is why I've chosen S asterisk S. In leftmost, I chose S plus S first. Okay, so the choice is important. That depends upon how you traverse. So S asterisk S I choose. then the rightmost non-terminal has to be replaced. Now I want a plus also, so I replace it with this. Okay, I replace it with this S plus S, and then I start replacing. So the rightmost terminal is replaced with C because C is expected in my string. Then the second rightmost plus I leave it as such. Okay, then B is replaced and then A. Okay, so while reading, we read it from the bottommost asterisk and the A. Okay, so we write it like this, B plus C asterisk A. Now this has a problem. We'll see this where we are seeing ambiguity. This is not the correct tree. Okay, this is not the correct tree. We'll see it why while we are seeing ambiguity, but still what we are trying to see now is rightmost and leftmost derivation. And also you should know that it is bottom to top. Okay, while writing the final string or while reducing the final string, you have to go from the bottommost operator first. So it's B plus C, then an asterisk, and then a A. Okay, so this is leftmost and rightmost derivation. Okay. Fine. So any doubts with this? So this tree is correct and that tree is wrong. We'll see why while you're seeing ambiguity. So now we are clear with what is a grammar, what is context-free grammar. Okay, formal definition of context-free grammar, context-free language. Fine. What is the derivation process? You should clearly know what is the purpose of non-terminals, terminals, starting point or the starting production rule and a set of production rules. Okay, and the process of generating strings via grammar. So all these things you should know by now. And derivation process can be done either in place, just substituting and then proceeding further, either from left to right or from right to left. Okay, you have to choose left to right or right to left depending upon the expression that you're going to generate. Okay, for the past trees. And you can do the same thing. Instead of in place substitution, you can do the derivation process via past trees also.